And with that, it's my great pleasure to introduce you to our next speaker, Florian Standhartinger. In his day job, Florian is a lead IT consultant working on large-scale geoinformation systems used, among other things, for early forecasting of hurricane damages for one of the major insurance companies here in Munich. Beyond his enterprise work, Florian is magnificently passionate about AI, something you very, very quickly notice when you talk longer than 2 minutes with him. It's therefore not surprising that he contributes to the AI innovation community, for example, by sharing AI news, research, and open source projects on his Twitter, now X account, if you want to follow him, AI Research 12. The topic of today's talk, though, is based on his contributions to Chutes.ai. If you think that modern AI systems can only stand on the shoulders of huge data centers built all around the world currently, Florian might teach us otherwise today, as Chutes offers fully decentralized inference platform at a fraction of the traditional costs by incentivizing independent hardware operators. Here to unpack it all, please welcome our speaker, Florian Standhartinger.
Yeah, oh, that's loud. Thank you and welcome everyone. Yeah, so I want to talk about Chutes, which is a decentralized AI compute provider. And I also want to talk a little bit how it's actually possible that a very, very small team of just a handful of people can actually compete with really big billion-dollar companies. And I think it's quite noteworthy. So, but at first, let me talk about what is actually happening if AI is becoming more and more powerful, maybe even surpassing human intelligence and grow further in the next coming years, or maybe it's 10 or 15 or 50 years. And it becomes basically an essential good like water, power, and the internet. Not a luxury, not a fun, geeky toy, but actually something that every person relies on every day, and like the children will actually need to be empowered to become like grown-ups with fair chances on this planet. So if you think this is possible, you quickly get aware that actually AI should become kind of a common good. There should be equal and fair access. It should be affordable to everyone. It should be permissionless to use it. It should be community-owned, probably. It's probably not ideal if profit-oriented companies have control over it and like authoritarian governments or like wealthy and mighty individuals. Or at least it's probably fair if they do, but at least there should be an alternative additionally that makes it more like open and community-owned and provides it to everyone on the planet. And yeah, I mean, that was kind of a heavy intro, super idealistic. It's actually not my thing normally. And yeah, this idea that actually technological breakthroughs should be available to everyone, fair and equal, I didn't care at all about this when I was a 6-year-old child. I just didn't bother about it. I was just not interested at all. I mean, I was a very skinny boy with beautiful blonde hair. People told me I was kind of cute, so I got this going. Life was good. All I actually cared about was, like, I had seen a very new technological breakthrough at a friend, like the big brother had what they called a personal computer, and I was super hyped about it. I wanted one, and I just begged my parents, please get me one. I actually still surprised they actually bought me one. And then I was even more lucky that even back then in 1987, my uncle was already having a software company, and he teach me like a couple of programming comments already. So like there was me, 6-year-old Florian, just super coding like a maniac, or trying, and that was just actually totally my thing. So I got this going, and still I wasn't interested at all in this idealism perspective on all of that. But maybe later, in hindsight, I would say that was kind of actually like really important for me that my parents gave me access to this, because it actually made me who I am today, and it comes into play in the rest of the perspective. So I want to quickly give a rundown how I actually got where I am today. So like my whole teenager time, I was like coding like a maniac, coding C++ games on DOS, 3D games, and I was just like amazed that you can actually just build things. And like quite naturally, because that was all I wanted to do, right after school I jumped into a job as an application developer. I got a really good job back then. They just let me do whatever I want, almost. Very lucky, basically. And that was like right before the dot-com bubble popped, so people were just still kind of excited that there are people that can turn coffee into code, basically. And then like I did this for a couple of years, and then went off and traveled the world for a year with my friends. And when I came back, like I was even more lucky. I ran into my wife, and we got married, we got children. So very, very much luck. I needed a proper job for paying the house and everything. I got a good job at MSG, is a great employer, and they sent me to a customer, Munich Re, also a great company, really nice people. And, oh, that was too early. Yeah, and actually I was also, once again, very lucky there, because what's not very typical in such an enterprise company, I had this chance to actually just like build like a maniac, whatever I wanted almost. And that's not very common. Typically they tell you what they want. And like I was able to build something like a one-man startup in there, and it grew kind of big, and the follow-up and side projects became a lot of people involved. So over time, everything became a bit more like process-heavy and bureaucratic, maybe. So that's fair. It's not a problem. It has to be. But just to get back this feeling of coding like a maniac and stuff, I started to do much more in my spare time. So I implemented a lot of like apps. I mean, that's just a few. Over time, I also got very interested in artificial intelligence, was almost only doing artificial intelligence then. And one of these things even, we had a chance to present at the Bavarian Minister of Digital Affairs, and I had this edit this morning, this picture, because that's Hannes. Hannes, I got you into the presentation, friend of mine. Yeah, and actually, like one of the last things I did, it got me to Chutes. And that was because for this app, I found out that I would need a very niche, rare AI model that has just been released, Molmo 72B. It was really good to identify like things on a screen to click at when you want to have autonomous computer use agents. You need that. And nobody did actually host this model. And then I managed to host it myself, but I quickly found out it's too expensive. I can't just afford this for a whole month. Just to hope I would get paying customers on the way. So I was looking for an inference provider, somebody who hosted this model and just like made me pay by large language tokens or something. And just on Google search page 3, I found someone, and that was a very unfinished web page. Everything looking very strange, and they actually offered this model for free. And I couldn't quite understand what was going on there, so I reached out to the people. It was actually hard to find out who was behind this project. So that's how I stumbled into John, who is a contributor there. And John explained everything to me, and that was kind of that kind of blew my mind. Especially when I found out that this is kind of an idealism project, actually. The idea is not to get rich, the idea is idealism. So If he sees that, he will kill me. Yeah, so basically you could say at some point I got quite a lot of interested in this idealism perspective. And also I got quite convinced that it might actually be possible. And now I would like to explain why. So, oh, okay, the animation order is wrong anyhow. What you need if you build a big inference provider is basically a lot of hardware, these super expensive GPU cards and stuff. And you need a data center being built, like new data centers even get an extra nuclear plant for the power. Super expensive stuff. Also a lot of complicated software involved. And you would like to have this, for our vision, you would like to have this global and decentralized, permissionless, community-owned, affordable, accessible, and then also it needs to become popular. And all of this is quite a big challenge, especially if you think about the whole world. Like it's super expensive to do that on a global scale. And it becomes even more challenging if you are aware who do you compete with. I mean, there's players like OpenAI who spends trillions on infrastructure. The EU spends like 200 billion. Mark Zuckerberg talks about hundreds of billions. So basically, it's a game of big players, big money, building up big compute because they expect a huge demand. And another aspect of this is that actually what is happening in the AI space is basically those models are often served a lot cheaper than they could actually be, because there is just, if you look at the AI-focused startups, they just have so much venture capital investments that they can basically just like burn the venture capital investors' money by offering the AI for cheap. And if you want to build up something and don't have a venture capital investor involved, it's pretty tough to compete with that. So this is how it works, actually. If you look at the clusters of compute on the planet, there is one very big cluster, we already said, like it's AI. A lot of compute on the world is used for AI. But there is actually one cluster that is way bigger. And this is a very conservative estimate. You can estimate it in different ways. This is a conservative one. And the second cluster where compute goes and is even bigger than AI, that's actually Bitcoin. Yeah, that's weird. And I mean, nobody's paying, like nobody's saying, guys, build a data center. They just do it. So how is this actually happening? There's miners, there's compute, and then there is the Bitcoin. And basically, miners just provide computational work in order to earn new coins. That's all it needs, basically. I hope there's no crypto expert involved that hates me for simplifying it down so much. But like basically, this is all that is needed to make sure those miners spend a lot of intelligence and set up really smart systems to do this more efficient than the others, because they want to maximize profit. So actually, for our idea of building like global equal access to AI inference, what Bitcoin brings to the table is actually quite a few nice things that match. Like it's a system where the self-interest of this miner just ideally aligns with the goal of the whole system, so it leads to a cooperative goal being achieved. It's permissionless, like a miner doesn't go anywhere. It's like, can I please mine? They just go and do it. And it scales without any central coordination. It's just like, it's a network, it grows. And it has already proven that basically this system of incentives can lead to like a global infrastructure of hardware running, which is very desirable for what we want to achieve. But there's also things that don't really match well. Many people criticize that basically Bitcoin doesn't actually produce commodities or goods. I mean, people inside of the Bitcoin ecosystem would say that's not true, but from the outside it may look like that. And also, like the consensus mechanism of Bitcoin, it doesn't actually, it isn't capable to quantify like how good did something work out. Like when you would serve AI models, you want to make sure these AI models are actually the ones you want to be served. You want to make sure they are served in a good quality and fast and reliable and no downtimes and all that stuff. So, and then there is BitTensor. So that's two of the founders, Jacob Steve, known as Const, and Ala Jabana. They were both computer science people. Const did work at Google back then, and Ala Jabana was an assistant professor in the University of Toronto. And one quote of Jacob is, BitTensor should be like a network where intelligence itself is the commodity, owned by no one, accessible to everyone. There is also a paper called like BitTensor, a peer-to-peer intelligence market. And as you can see, there is like, now I got to try this thing out. Here. There is even people on the list that are anonymous, like it is in crypto. So it's not only those two guys, actually. And now if you compare Bitcoin, like Bitcoin, if you dumb it down super extremely, it's just like those crypto coins are flowing into the pockets of the miners. And then if you compare it with BitTensor, it starts similar. There is like crypto coins, it's called BitTensor Tau, and it flows into something that is called a subnet. And the BitTensor subnet also has a miner in there, and the miner just does the same thing as in Bitcoin. It just wants to get rich. So it basically tries to do everything needed to get these crypto coins. But then in BitTensor, there's also a role called the validator. It's also permissionless, like somebody could come and could say, I'm a validator. And those validators basically task the miners. The miners send back the results to the validator. And then what the validator basically does, it scores the quality of what the miner did by a thing called the incentive mechanism. That's something that is hard-coded into this subnet. And basically, if you keep it simple, it's a bit more complicated, but just to explain the rough concept, that's how it works to decide if a miner gets zero emission because it didn't perform well, or if it like gets a lot of money. So this system, basically, as simple as it is, it leads to people coming and doing exactly what you want them to do, and you don't have any business with that. Super simple, actually. And yeah, if you look at that now again, things that have been missing in Bitcoin, like energy spent without producing useful output, that's now different. Yeah. So basically, like now we've got a mechanism to ensure what those miners do is produce actually what we want them to do, like AI models, for example. And also there is a way to check if what the miners do is actually good. Yeah, and so let me explain how this is transferred into Chutes in this AI-inference network I want to talk about. So Chutes is a subnet 64 in BitTensor. And people come, like people or applications that want AI model requests being answered, they come and send a request to Chutes. Chutes then like has its repository of open source AI models. There's stuff in there like the meta models, the recent open source models from OpenAI. DeepSeek are one that basically crashed the stock market a bit in the US when they released R1. And TNG, like this, woo! Yeah, it's actually a really well demanded model hosted on Chutes at the moment. Chinese companies very big in open source, like Alibaba's Qwen, Mistral, European company. So I've got those open source AI models. And then there is a lot of GPU compute servers. And those GPU compute servers are super expensive. In Chutes, they're not actually needed to be part of Chutes, of the organization. There's no building where you have like a lot of compute. It's just like the miners bring them. And the validators basically check. They implicitly say, you got to serve these models, and the miners do that. And then the models come back, look what I did. The validators analyze that and score that and say, okay, you're a good miner, you get a lot of money. So if you look at this incentive mechanism in detail, there's a lot of different components to it, and it's just a flexible system you can change. Like, of course, the amount of time your GPUs ran, and like if it's more expensive GPUs or cheaper ones, that's part of the equation, and the numbers of requests being served, and if you're a miner that serves, the only one that serves a certain model, nobody else does it, that could get you a bonus. And then there's also bounties. Like, for example, if there's a new model released, like the hype cycle in AI is super fast, you try to be the first inference provider to serve it, actually. And this basically also gets miners an incentive. And what is really interesting about this mechanism, like a lot of things interesting, the longer you think about it, the more you find interesting about it. That's how I see it. But one thing is actually, you would be impressed how smart those miners are in fulfilling these incentive mechanisms, because they just compete and they want to get more of the share. So I believe, I mean, if you would have a traditional company and you tell your people you are the ones that have to provide like the GPU inference, you typically don't have like 10 competing ones, and the better ones get paid more and the worst ones get kicked out of the system. So it would be a pretty tough job if it would work like that. But it's like just super hard Darwinistic capitalism in play here, like the good parts, I would say, of capitalism. There's certainly bad ones as well, but so this kind of just works. And you shouldn't forget, it's also just still completely open. So you could just look at the incentive mechanism source code. It's open source. If anybody of you wants to change it, go for it. Like, hand in a pull request. If it's a good idea, the team will look at it and will say, yeah, cool, let's change it. And interestingly, it will be just like 10 minutes afterwards, the miners have adjusted, because like the miners are competing, they try to do what gets them money. So it's such a powerful system, actually, so simple and still so powerful. I got totally hooked on that. yeah, to be honest, that's why I'm here. All right. So yeah, that was very abstract so far. So let's just take a quick turn to how it actually looks. Like the one way you could look at it is just a homepage of basically Chutes.ai. Nicely designed. Oliver, who does the front end and the design, is just really good designer. You would find like a chat application there, like the ones you know, also working smoothly, can do lots of nice things like generate images or speech-to-text input and all of that stuff. You would find a section there where you get the list of open source models available. I think it's something like 236 or something. And for each of these models, for example, you could see very simply the source code needed to integrate this model into your application. If you're implementing an AI-infused application, you would just go there, copy it into your application, you're good to go. So it's kind of simple. And also, here you can just look at the code, how this model is actually hosted on Chutes. So basically everything is still open. And then there's also a noteworthy thing. There's even some models offered for free, which is kind of interesting if you think about how expensive this hardware is. So yeah, I mean, nice story so far maybe, but it's fair to be suspicious if this actually works. And turns out it is. So Chutes is like currently #1 among the open source providers. Yeah, thank you. Which is just weird. I mean, you gotta see how much money these other competitors have. Why is this working? Yeah, kind of weird. So yeah, OpenRouter is like this biggest marketplace for AI-inference in the internet at the moment. So that's why they are very interesting to look at statistics, because they also publish a lot of their statistics. So basically, you send your request to OpenRouter and say, I just want DeepSeek R1 answer, what is the meaning of life? And then you just send that to OpenRouter, and OpenRouter decides which of the inference providers that serves R1 gets the actual request by analyzing like how fast are they, how reliable, what's their price, and if one of them has an outage, you would get it load balanced to someone else. So that's what OpenRouter does very successfully. It was a really small startup like 2 years ago. I watched it closely, and now it's super big. And yeah, I mean, if you look at that, it's actually like among these open source providers on OpenRouter, Chutes just serves the most at the moment. It's like 35 trillion tokens per day. Like a token is roughly 1.3 tokens is a word, roughly. I mean, still it doesn't really help, because nobody can actually imagine what 25 to 30 trillion words would look like. Let me look. Oh, it's billion. Sorry, I said trillion. Wrong, billion. So there you see, those numbers are too big. I can't really relate. It's just too big. But thank you. Yeah, that still it's really big. And that's even though OpenRouter actually disables Chutes by default, which is weird. Like, because they actually say they can't actually ensure that this provider doesn't take this data you send there for training. We are not. I mean, we're also actually doing a lot to prohibit anybody looking at the requested responses. We're not logging them or anything. But due to our decentralized nature, and we don't know the miner and everything, at the moment we can't 100% be sure that the miner doesn't do super sneaky things and get some look at the request yet. So basically, you actually have to switch a toggle, show ignored providers. You have to go into a very deeply nested menu on OpenRouter to turn on even these kind of providers, and still we're like number one. That's just kind of mind-blowing, especially if you think about that we're really close to getting TEE, trusted execution environments implemented, which then will totally guarantee that nobody can look at it and nothing can be tampered. And I guess it's days or weeks out, and this will remove the red flag. And I'm really looking forward to see what this does to the statistics, and also it opens up doors to a lot of other inference marketplaces. That's going to be really cool. Yeah, there's other things to look at to say that this is actually working out. So there's a lot of growth in users. Like, this project just started in January, and it actually just picked up users in April, and now it's like a steady growth. And I think it was around this time where you could see it's not as steep anymore, when Chutes stopped serving everything for free, and now they're charging money, but still you can see growth. And so it's actually not killing the growth, which is a really good sign. Then it's also interesting to look at that there is actually thousands of GPU instances running in Chutes. So it's literally thousands. And if you look at these, like the biggest bubble here, that's NVIDIA H200s, like where one of those is on Geizhals. I didn't know you could buy GPUs on Geizhals. That's interesting. It's okay, it doesn't work. It's one of those costs like 28,000 euros, something like $30K dollars, and it's literally thousands. Or the B200s, it's also roughly that price, even more expensive probably. Another thing you can see is that basically the revenue is already rising nicely, which is we've just like Chutes has just started to charge anything not long ago, and it's rising nicely. Another thing to look at is this growth curve of tokens provided to the world. And if you, I mean, here it said, that was just like until end of May, like half of the year. And it said like 3.6 trillion tokens processed so far. I just looked it up this morning. It's 11.4 now. And if you compare that like OpenAI, this was the tweet by the OpenAI CEO, Sam Altman, in February 2024. So, I mean, they have grown since then, but at least, I mean, look at it, it's OpenAI, and 2024, there was the AI hype going already since quite a while. And that's roughly the same number. Because if you look at it, it's like, this is a statistic from October. I can't get this working here. Anyhow, it's 135 billion tokens on a day in October, and that's by the rule of thumb, like 1.3 tokens per word. That's roughly that number. Another way to look at it is if you look at like competitors on OpenRouter, you would see the market capitalization or valuation of Chutes is super low, like it's 100 million. You have to see that's a logarithmic chart on both axes. So basically, Chutes is worth 100 million right now, and like other competitors are like in 30 billions or something. And of course, there's this whole bunch of actually model labs that produce models. That's a whole different thing, of course. But the ones that are only inferring, like providing inference, are still valued a lot higher typically. And at the same time, Chutes is providing like so much inference per day, and it's actually investable. So if you look at this from an investor perspective, many of these others, I mean, you couldn't buy into Anthropic, except if you have like 10 billion, maybe somebody would talk to you. But if you have like $100 and would like to buy into it, like buy a share, you get to think like, how much share would you even get for $100 from a company like Google that is 3 billion? It's percentage-wise a very small share. And in Chutes, basically, you can buy 1% of the whole share for $1 million. $1 million wouldn't get you anywhere in those big companies, really. So basically, it looks like we're leading the peer group by volume, have an extraordinarily low market capitalization right now, and are actually investable. And if you look at it like this, it becomes even more mind-blowing if you really compare the numbers of daily served tokens on OpenRouter with the market capitalization or valuation of this company. It's just nuts. The comparison is just crazy. Yeah, so all of this is no investment advice. Not at all. I'm just looking at numbers. So yeah, and to recap, it's all about the incentive mechanism. Oh my God, I'm talking for way too long already. No? Okay, fine. I'm sorry about this. Let's make it a bit shorter. So yeah, basically it's all about the incentive mechanism. And if you look at BitTensor, it's not only. Oh really? Huh. Why does it show 56 minutes? Weird. Okay, I know, because it was running already. Okay, that got me scared. All right, so BitTensor is actually consisting of a lot of subnets. So Chutes is not the only one. There's like subnets like Chutes, subnets for AI inference. There's also subnets for AI model training, decentralized training even, which is very interesting. There are subnets for model fine-tuning, subnets for AI coding assistance, subnets to produce training data, subnets to provision raw AI hardware. So basically, this whole BitTensor is a bunch of startups in the AI ecosystem. And also, because it has this property of being actually a crypto network, it can be traded, and there is a lot of competition built into it. Like these subnets are competing among each other, and you can look at the charts, you can buy into a token and sell it later and stuff like that. There is a main currency, which is BitTensor Tau, and like every subnet has its own derived currency, basically. So there's a Chutes alpha token, which is derived from Tau, but has a different value, and you could just like buy into that one. And if you look at this, at the moment it's like there's 7,200 Tau emitted every day. And one of them is roughly around 380, sometimes 400, sometimes 300 dollars, so that's like $1 billion in a year that flows into the subnet. And like Chutes is currently on #1 and gets like 7.8% of this share. So that's quite a lot of money every day. And you have to be aware that actually all of this is permissionless. Like you could just sign up as a miner, you could just sign up as a validator, which requires a bit of capital, but you could just get in basically. You can actually just buy a subnet. There is also some other interesting properties probably. So there's only ever gonna be 21 million tokens of tau, and like half of it is already emitted, and many of that is also locked away, and it's also kind of small share that is fluid around, which is probably gonna hopefully rise the price quite a bit, like it was happening in Bitcoin, because there is also like a halving cycle built into the system. So like in December, we will see the first halving. Then it's not 7,200 coins emitted a day, it's 3,600 then, and that gets lower and lower, which means like at some point all of the tau are out there, or just a very low share gets emitted a day. And then if things turn out right, then it can actually be that those taus are quite valuable, because it's a very rare commodity to have. So yeah, I mean, the longer you think about it, at some point you probably get to this conclusion: I should start a subnet. Yeah, so that's about BitTensor, and then some utopia, basically, or actually just things that are coming up. Of course, Chutes needs to produce more revenue, because it's not like working like a Ponzi scheme or anything. You could just like not forever rely on these tokens paying you. Those subnets are competing, and the ones that don't start to produce revenue will probably get downvoted by the investors and stuff. So kind of it's more like a venture capital, like a startup accelerator. This whole BitTensor, you basically have a good share of startup capital at the beginning, but then you kind of have to prove that you can compete on the market. Of course, this encrypted inference stuff, TEE, is coming up. A lot of satellite apps, like the chat app already, and there is quite a few at play. I'm also working on that kind of stuff. There's a lot of other interesting apps you can build with AI. More borderless, payments actually, to actually really make it easier for people everywhere in the world to participate. And actually, in a long-term goal, is really the plan to have this completely community-owned and self-controlled and self-organized. So it's like really the contributors of Chutes, like the team members, they don't want to like own it in the long run. The actual goal is it should be like kind of a present to the world. The world should just have it community-owned, and it should just be out there like Bitcoin is out there and nobody can stop it. It should just be a system that exists out there in the world and provides affordable and cheap inference to the world. Yeah, thanks. And then that's just like one thought experiment that's not actually happening yet. But one of the core problems with AI is also that it like consumes so much energy, and that's not good for the climate probably. And we have just like discussed it, that basically, if you think about it, there's always somewhere in the world it's always summer, somewhere it's always daylight. And if you look at how the prices for GPUs have developed, they are falling very quickly. And many people actually say at some point the biggest share of AI inference cost will be energy costs. And what's the cheapest energy? Cheapest energy is basically excess renewable energy. Like in Germany, when you have in summer, when you have to throw away all this solar energy. So basically using excess solar energy is not bad for the climate. It's actually not a problem at all. So our idea is, because we are so decentralized and not like a big AI startup in the US just builds a huge compute center in the US we're just like people from all over the world will probably come and they want to maximize for profit as a miner, and they will probably at some point go and just say, okay, I'm just starting a compute in a region of the world where it's summer and where it's daylight right now. And we could probably even try to get this somehow into the incentive mechanism, like many other ideas you could put into the incentive mechanism at some point. All right, so that's actually all I wanted to say. Let's make sure life is good for the generations ahead, and ensure artificial intelligence is just like owned by no one and accessible to everyone. Yeah, that's it actually. Thank you.
Thank you very much, Florian. Do we have any questions in the audience?
Yeah, thank you so much for this talk. Well, of course, thank you for hosting our models as well. Anyway, since you are a validator in your subnet, if I got it right, how do you both measure and actually validate that your miners have done this computation power that you expected from them?
Yeah, it's a good question, and there's a lot of components at play. I guess John could explain it a bit better because he's working on the validator code more. But yeah, I mean, actually, there's a lot of encryption going on when the miners basically download a pre-compiled image of the whole model computation. And basically, it's like a Docker image or like a container image that already contains everything, like the model and the inference code and all of that stuff. And then there is a lot of low-level code running on the miner first before it can actually start to run. It checks which GPUs are actually on this system. It checks if any network connections are going out there or any tricks are going. And it actually is a very hard struggle to set up a subnet that actually works in the first weeks or months, because like miners will try to exploit. And it's actually a very interesting cultural thing in this BitTensor. I was actually surprised to see that exploiting hacking is just appreciated. People say, come on, exploit me. Like Konst, the founder of BitTensor, started a subnet recently, and one of the first things he said, come on, exploit me. Come on, guys, where are you hackers? Because they actually want to make sure this subnet goes through this forging of being battle tested to ensure it's actually working.
More questions?
Thank you so much for your really enthusiastic talk. I can understand it. So like large language models are simple in the sense that like the input and the output is like relatively small from a data point of view. If you're working with images and like image data sets, this can easily become like data sizes in the terabyte or even petabyte range. Is Chutes also able to handle such workloads, like where you have like a lot of data, and how does this work?
Yeah, we do that actually. We've got like image models and video models on there, like WAN 2.2. We got a really fast version of WAN 2.2 running, where you can produce videos. And yeah, I mean, it just works. The infrastructure costs quite a bit of money already. It's like, I think the Postgres database that does not really log requests or responses. It just logs that there was a request by anonymous ID of a user coming in and a couple of statistics. This Postgres did already cost something like $50,000 per month now, because it's so big and we have to move it somewhere else to get it cheaper. So it's like, of course, like the infrastructure gets a bit heavy, but the long-term plan is to try to move all of this infrastructure into decentralized ways and probably even incentivize miners somehow. You can, there is a thing like subnets. You can also kind of say there's not only one role for the miner in this subnet. There is like, you could also register as a miner that does a certain other part of this work, and we could, for example, try to get people to handle parts of this infrastructure load. But there's different options in discussion. There's nothing completely decided yet. It's working out with videos and these bigger loads, but in the long run, we'll probably just need to become completely decentralized, because also the centralized way, it requires somebody to have the admin key and stuff, so you would still have single people at play, and you don't want this in the long-term vision. But there's a bit way to go to get everything solved.
So thanks for the great talk. I really liked it. So I was wondering, let's say I go to Geizhals and buy a H200 for 28K, right? So what do I actually need to do to become a miner? And then also, second part of the question, how decentralized is it actually in the sense that you have like small miners versus you have big data centers, right? You see what I'm getting at?
Yeah.
Okay.
So basically, registering as a miner is pretty simple. I mean, you need to have a bit tensor wallet set up. You're basically doing this on the terminal on your computer, and then basically it's a couple of command line calls, and you're registered as a miner. It costs a little bit. No, I think in Chutes it's even for free. You can just register, and then you need to basically read through a README and install some stuff on your machine, and then you're set up, and then you're a miner. And like everything in BitTensor, it's very competitive. So like, for example, the worst miners get kicked out of the system from time to time and have to re-register. And in some subnets, registering as a miner is super expensive. You would have to pay a couple of €1,000 to get registered, so you really don't want to mess up, because when you lose your spot, it's expensive. So yeah, but in Chutes, it's not like that. You can just go and register. This other question, how decentralized is it actually? I think it's something like 50 different miners currently providing the compute, and it's true there is data centers involved, but there's also individual smaller ones. Of course, they don't earn so much money, but if you're a private person, maybe it's cool. Still, you have to be aware the prices we can pay for the GPU with this system are not incredibly high. It's just like, it's a very efficient market, basically. The people compete super hard and try to be cheaper than the others, so it's just working out really nice. And like the opportunity cost, what can you actually do with this GPU somewhere else to earn something, is rather big. But also there is like data centers that have spare instances around. Like you've got a data center with 1,000 H200s, and like only 900 of them are currently rented out. Some of those data centers have started to just use the other 10% for Chutes, because it's better to earn like a little bit than nothing. So the opportunity cost of 0. That's why we're actually able to do it rather cheap.
Yeah, hi, thanks for the talk. I had a quick question. So you mentioned that, obviously everyone can see how you can envision attacks like, oh, I report that I used 200 H200s, and the answer to your question is you're a cat. How many of those types of attacks have you seen, and what do they generally look like? Because it seems like the main thing that the validators and in the contract that you're trying to prevent. So I'm curious, how much of that exploitation has happened so far, and what does that generally look like?
Yeah, I mean, I can't answer everything here probably, because most of the problems have already been solved when I joined the project, basically. This stage where the subnet struggled with attacks, I think seems to be over. I think at the moment it's like those miners just have to comply, because they don't find any ways to hack the system anymore at the moment, looks like it. But yeah, I guess they would try all sorts of tricks, like, for example, also just like installing their own AI models. Chutes can also be used to just upload your own AI models and serve them to the world. And those miners would upload their own models and then serve them and like get cash into their own bucket, stuff like that. Some would even probably try to hack the validator code, but some of the validator code is like the only stuff that is not really open sourced yet, because you don't want them to see some of the tricks the validators do. Most of it is open source, but some of it is really low-level C code, checking a lot of internal APIs. There's stuff like the whole Python stack gets basically intercepted by the validator to check really what is running in there. Lots of super deep level tricks. And yeah, those miners would basically try everything. It's like, if you can get free money, why shouldn't you?
It feels like there's a lot of power in those people who set the incentives. And you're a good guy, so you try to make the world a better place. But have you ever thought about what happens when someone evil joins?
Yeah, it's actually a good question. It's actually a good question. I don't actually know. If somebody starts a subnet where the incentive is kill as many people, wow, never thought about that. Yeah, I don't actually know. That would be a question for cons, like the BitTensor guy. I guess what would probably happen is this subnet would quite quickly be rated down and then would be deregistered. There is also this competition among the subnets, like the worst subnets get deregistered, so you're kind of trying to swim and not get registered. Be a good subnet, otherwise you will be basically at the end of the leaderboard and will get deregistered. So probably that's gonna happen. But I think setting the incentives in a decentralized, community-owned way will also be kind of challenging. But I mean, open source projects are also community-owned, and it works out somehow. Like somebody's trying to get a security backdoor into Linux, and will just fail because people are watching closely what's happening there. And I hope it's going to turn out like this.
We have time for one more question. All right. Oh.
Hey, thanks for the talk. This is probably a stupid question, but you said these subnets are numbered, and Chutes has number 42, is that correct?
64.
64, oh, okay, sorry. Okay, thanks.
Yeah, no, that's true. That's at the moment there is just like 128 slots of subnets, yeah. And I mean, somewhere earlier got earlier slots. It's also not sequential. You can just, if there is a free spot, you can just buy that one. It used to be very cheap when I got into this like this year actually, and subnets could be bought for as low as like $20,000, and you should have done that because it gets you very rich. It can get you very rich if that's what you're after. And now a subnet is like $280,000, so it's not so easy to buy one anymore. And actually, it's almost all spots are full now. So from time to time, one gets deregistered, and then there is kind of this price battle who buys it. Yeah, that's how it's working actually. And maybe in the long run, they will open more spots. That's in discussion. Maybe at some point it will be 256 or unlimited, I don't know.
Okay. Florian, thank you very, very much for honoring us with
thanks for having
this really
me.
interesting talk. Thank you, guys. And I guess lunchtime is open.
Yes.